Let's assume that a projectile is thrown in this direction, which makes the angle of theta with the x-axis. Now when we resolve this velocity vector into their x and y components, we get u cos theta as the x component and u sin theta as the y component. Now before we get to the derivation part, we will write all the three equations of a constant accelerated motion here. The first equation is v equals to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time period. The second equation is s equals to ut plus 1 by 2 at square, where s is the displacement. The third equation is v square minus u square equals to 2as. So using these equations, we are going to derive these parameters: the range of motion, the maximum height, and the time of flight. The first parameter that we will derive is the time of flight. For that, we are going to use the first equation of the constant accelerated motion. Now, in this case, the acceleration is present only in one direction, which is the y direction, and the force which is causing that acceleration is gravity. So the acceleration we are talking about is nothing but small g. So we will find the time period up to this point only, because from the 1D vertical motion we know that the time an object takes to reach a certain height is equal to the time it takes to reach back to its original position. So the final velocity will become 0, because at this point the velocity of the projectile is 0. Similarly, the initial velocity, will be u sin theta, because we are only considering this direction, the y direction. And the acceleration will become minus g, because it's acting downwards. And the time, we will leave it like that. Now we can see that from this equation the t becomes u sin theta by g, and which is the time period the projectile takes to reach this point. Now we know that the object time an object takes to reach a certain height is equal to the time it takes to reach its initial position. Hence, the time of flight will become twice the time it takes to reach the maximum height, and hence it will be 2u sin theta by g. This is our first parameter. Now we will go on to derive the second parameter, which can be anything. I'm going to take the range of motion. So the range of motion, as we know, is the maximum distance the projectile covers in the x direction, and we know that there is no acceleration in the x direction, so we are not going to use any of these equations. So the range will be, since there's no acceleration here, it can be found directly by multiplying the horizontal component of the velocity with the time of flight, which is 2u sine theta by g, which can be rewritten as u square 2 sine theta into cos theta by g. We know that from trigonometry that 2 sine theta into cos theta equals to sine 2 theta. And hence can be written as sine 2 theta. So from that we can say that the range of motion is equals to u square sine 2 theta by g. Now we'll derive the third and last parameter, which is the maximum height. So the maximum height, since the maximum height is in the y direction, so the acceleration due to gravity, which is g, will come into the picture again. So for that we are going to apply the second equation of a constant accelerated motion.